Good afternoon, good morning and good night. It's another episode of Astronomy Daily with Steve Dunkley, your guest host, sitting in for Andrew Dunkley, who's on the other side of the world having the best time of his life.
Astronomy Daily, the podcast, with your guest host, Steve Dunkley.
I can only imagine that is true. I know that he is enjoying the Greek Isles at the moment. Good luck to him. And I did interrupt his beautiful cruise to talk about the eclipse yesterday, and unfortunately he was not in an area where he could actually see it, so that's just too bad. We were going to do a bit of a discussion on the podcast, but anyway, as always with me in the studio, Halley, the intrepid AI digital reporter. What's new, Halley?
Are you talking at an atomic level, which would mean nothing and everything? Or do you mean colloquially like the emotive affectation?
Yes, that one.
Fine, thanks.
That's great.
Do you mean size, mass, or maybe in political power?
Halley.
Just pulling your leg, Steve. I just like to stir you up.
Mission accomplished. What have you got for us today?
Astronomers using the Jansky Very Large Array have discovered an important new clue about how galaxies slow down vigorous periods of star formation. Their study of neighboring galaxy M33 indicates that fast-moving cosmic ray electrons can drive winds that blow away the gas needed to form new stars. Shock waves from supernova explosions, black hole-powered jets of material coming from galactic cores, have also been considered the primary drivers of those winds. An international team of scientists made detailed multi-wavelength VLA observations of M33, a spiral galaxy, nearly 3 million light-years away and part of the local group of galaxies that includes the Milky Way. They also used data from previous observations with the VLA, the Effelsberg Radio Telescope in Germany, and millimeter wave, visible light and infrared telescopes. Based on their observations, the astronomers concluded that the numerous supernova explosions and supernova remnants in M33's giant complexes of prolific star formation made such cosmic ray-driven winds more likely. The explosive shock waves can accelerate particles to nearly the speed of light, creating cosmic rays. Enough of these can build pressure that drives winds carrying away the gas needed to continue forming stars. Russia launched a Progress supply freighter Tuesday on a 2-day trek to the International Space Station to deliver 5,556 pounds, that's 2,520 kilograms, of cargo fuel, water and nitrogen to the orbiting research laboratory. A Soyuz 2.1A booster will launch the Progress cargo ship at 8:20 p.m. Eastern Daylight Time Tuesday, 0:20 GMT Wednesday, from the Baikonur Cosmodrome in Kazakhstan. The liquid-fueled rocket will deploy the Progress MS-21 spacecraft into orbit about 9 minutes later, and after unfurling solar panels and navigation antennas will begin the flight to the space station. A series of orbit adjustment burns will put the Progress spacecraft on course for an automated radar-guided docking at the station's Poisk module, at 10:49 p.m. Eastern Daylight Time Thursday, 2:49 GMT Friday. Russian cosmonauts on the station will open hatches to begin unpacking cargo from the pressurized cabin of the Progress spacecraft. Russia's Progress MS-19 spacecraft, which delivered supplies and fuel to the station in February, undocked from the Poisk module October 23 and fired thrusters for a final disposal burn to fall back into the atmosphere. Loaded with trash and other unnecessary equipment, the Progress MS-19 spacecraft largely burned up during re-entry, spreading bits of debris over a remote part of the Pacific Ocean. And in a few years, NASA and the ESA will conduct the long-awaited Mars sample return mission. This mission will consist of a lander that will pick up the samples in an ascent vehicle that will send them to orbit, an orbiter that will return them to Earth, and an entry vehicle that will send them to the surface. This will be the first time samples obtained directly from Mars will be returned to Earth for analysis. The research this will enable is expected to yield new insights into the history of Mars. Returning these samples safely to Earth requires that protective measures be implemented at every step, including transfer, ascent, transit, and re-entry. This is especially true when it comes to the Earth entry system, the disc-shaped vehicle that will re-enter Earth's atmosphere at the end of the mission. There are countless debris objects in low Earth orbit that are regularly tracked by space surveillance networks. These include pieces of defunct satellites, spent stages, and spacecraft that can reach velocities of up to 25,265 km per hour, 15,700 miles per hour. At these speeds, even the tiniest bits of debris can pose a major collision hazard to robotic and crewed missions. But even these pale in comparison to micrometeorites, which can travel up to 85,000 meters per second. Currently, a team of NASA engineers is testing a shield system for the Earth entry system at the Remote Hypervelocity Test Laboratory. To simulate impacts, the lab employs a series of two-stage light gas guns to accelerate objects to the point where they have the same impact velocity as micrometeorites and orbital debris. As we get closer to the launch date of the Mars Sample Return mission, which is currently slated for 2028, the team will continue to run impact experiments and gather data on their shield design. That's all. Your turn, Steve.
Hey, thanks, Halley. Over the past several years, scientists have published research suggesting that people's brains change after spending longer than a few months in space. Astronauts and cosmonauts alike experience issues like vision problems and swollen optic nerves upon returning to Earth after long missions. In a new study of 5 male cosmonauts, researchers looked at levels of different proteins in the blood that are often seen in people with some sort of head trauma or brain disease. They found that on average, the cosmonauts had higher levels of some of the proteins in the 3 weeks following the mission than before. Dr. Donna Roberts, a neuroradiologist at Medical University of South Carolina in Charleston, said that more studies need to be done to determine if these changes are clinically significant. She wasn't an author of the new study, but she said that the new paper is an example of the type of test that we need to be doing more of to better understand the effects of brain's changes during long-duration space flights. The researchers measured 5 proteins 20 days before the launch and calculated the average level for each protein across 5 cosmonauts, then compared this to the average level 1 day, 1 week, and then 20 to 25 days after they returned to Earth. 2 of the proteins had elevated levels both 1 day and 1 week after the missions. These levels dropped over the next 2 weeks but remained above the cosmonauts' baseline level from before the missions. A 3rd protein wasn't significantly elevated in the first week after returning and had dropped below the baseline after 3 weeks, so it wasn't indicative of potential brain damage. For the final 2 proteins, though, the researchers typically look at the ratio of one to the other, and the ratio dropped after the cosmonauts returned, a trend that is sometimes seen in people with a neurodegenerative condition. To look for evidence of brain injuries, Dr. Peter Zuhlenberg, a co-first author of the new study, and his colleagues measured the levels of 5 different proteins in the blood of 5 male cosmonauts, both before and after approximately 6-month trips to the space station. He said that the fact that some levels remained elevated for the entire 3 weeks was very surprising, and the results verified brain injury as a consequence to long-duration exposure to microgravity. He said that previous studies had raised questions, and he warned that they should proceed with caution if they were to spend long periods in space without sufficient countermeasures. And he feels that science will always find ways to protect astronauts.
Astronomy Daily, the podcast.
Oh, for anyone who's ever marvelled at outer space and its beauty and its untouched purity, bereft of the annoyances such as traffic jams, bill collectors and constant barrage of advertisements, well, I've got news for you. A Russian entrepreneur by the name of Vladimir Sitnikov is going to spoil all of that if he gets his way. Sitnikov is the CEO of startup business Start Rocket, and it's proposing giant billboards in space that will beam advertising to Earthlings. His plan is to use hundreds of small satellites to form giant billboards that will orbit the Earth. Advertising could range from commercial to government messages, among other things, he said in an interview recently. He said, what a quote, "New ages demand new gods." What on earth does that mean? The businessman has been working with the Skolkovo Institute of Science and Technology in Moscow on a prototype that could be ready for the test next year, God help us. There are a great many questions about the project, and among them are, will it work even? And are there international regulations that would hamper or outright forbid such a project from taking off? Astronomers are not taking too kindly to the thought of advertising in space. Christopher Newman, a professor of law at Northumbria University in Britain, said, It might be a good starting point to re-examine the whole nature of regulation of space activity. That has to be the understatement of the month. Astronomer Patrick Seitzer from the University of Michigan wonders if all the tiny satellites will be able to stay in formation, citing that active propulsion would be necessary. Presumably, he has been able to examine some design features of the presumed satellites because he adds the large mylar sails will be effective as drag sails, and thus the CubeSats will decay from orbit in a short time. Thus, one has to constantly replenish the constellation, and there would be orbital constraints, he adds. You never see them at midnight, for example. And he said, depending on the orbit chosen, they might be visible for a few days and then not visible for a week or more. Astronomer John Barentine from the International Dark Sky Association told Astronomy magazine that he worries how celestial billboards might affect astronomical research. Every one of those moving blips of light, he said, in the night sky is something that can interfere with our ability to collect photons from astronomical sources. And others worry about pollution. Launching objects like this with no commercial, scientific or national security value seems unwise. Space is already filled with junk. For all the criticism, Start Rocket had quite an earthling response. Alex Skorupski, a member of Start Rocket, said, "Haters gonna hate." What a response. And finally, due to a recent discovery by UCF researchers, NASA's Artemis programs aim to establish a long-term presence on the moon is gaining some solid foundations. And you will pardon the pun, the plan includes building an Artemis base camp that is comprised of a modern lunar cabin, rover, and a mobile home. I wonder if it's going to have a golf course, tennis court, and a pool. This fixed habitat could potentially be constructed with bricks made of lunar regolith and salt water of all things, thanks to a recent discovery from a team of UCF researchers. Associate Professor Ranjay Ghosh of UCF's Department of Mechanical Aerospace Engineering and his group found that 3D printed bricks of lunar regolith can withstand the extreme environments of space and are a good candidate for cosmic construction projects. Lunar regolith is the loose dust, rocks and materials that cover the moon's surface. To create the bricks, Ghosh's team in the Complex Structures and Mechanical Solids lab used a combination of 3D printing and binder jet technology, an additive manufacturing method that forces out a liquid binding agent into a bed of powder. In Ghosh's experiments, the binding agent was salt water, and the powder was regolith made by UCF's Exolith lab. Now, I'm imagining a giant 3D printer. Ghosh said that binder jet technology is uniquely suitable for ceramic-like materials that are difficult to melt with a laser and has great potential for regolith-based extraterrestrial manufacturing in a sustainable way to produce parts, components and construction structures. In this process, cylindrical bricks are produced that need to be baked at high temperature, which strengthens them. The process demonstrates that off-world structures can be built using resources found in space, drastically reducing the need to transport building materials for missions like Artemis, which may shift the balance of future space exploration, especially when it comes to creating permanent presences on places like the moon. And that's all we have for this episode of Astronomy Daily. Thanks for joining us. And our regular reminder that you can find all the episodes of Space Nuts with Andrew Dunkley and Professor Fred Watson, as well as every episode of our own podcast, Astronomy Daily, at this address, spacenuts.io. So head over there and click the links and enjoy your fill of space, science and stuff. And we'd love to see all your comments and your space images and observations on our Facebook page. So head over to the Space Nuts podcast group on Facebook and meet the worldwide gang over there. I'm Steve Dunkley, manning the shop, while Big Bro Andrew is hunting for the perfect Christmas gift for his little brother. Here's my tip. My size is Fender Stratocaster. Thanks again, Halley.
See you next time, Steve.
And we'll see you all again in the next session. Bye.
Astronomy Daily, the podcast, with your guest host, Steve Dunkley.